Hello world, I'm Solve.Problemo, and today I'm starting my LeetCode cracking series. This series is not just about explaining the LeetCode solution, but this is more about my journey and I just want to record this video for myself. So the first LeetCode problem that I faced was from the Programming Skills study set is merge strings alternately, and here we have basically two strings, like in these examples, and the idea is to create a new string just by appending one character from one string in the second character from the other string, and we repeat this until one string is finished, and then we append the remaining one to the final string. The main idea is probably pretty easy, but for me it was not so, but still I tried my best. So, and constraints is the most valuable thing when you solve LeetCode problems. So paying attention to constraints is really matters, and exactly for this problem we have these constraints. So I'll explain why they actually is a little bit later. So here we have different examples, and when I actually think about each problem, I try to ask some questions, and the main question for this problem was what given constraints tell me. So, and in general, constraints mean what inputs are possible, and actually it shows what approaches can be used and which are efficient or not. And this is some basically main things here is the input size, the what type it is, maybe Unicode or ASCII characters, or edge case guaranteed or not, and everything about the complexity we can see through the constraints that is given in the question. So, and coming to this question itself, we have this constraint, which shows the range of word lengths, both of two strings, which is up to 100 characters. What it tells us that both strings are not empty. So this tells us that it's not so more than 1 or equal to 1, which means strings are not empty, and so don't need special handling for the empty string, and code that works with empty string is not required. This is basically actually the constraints for the easy questions, easy problems. And later, when we will solve other problems, we will go through each of these constraints, and they will tell us why this particular problem is set, and so it will tell why this problem had this type of level. So, and next is word 1 and word 2 consist of lowercase English letters, which tells us that characters are only from A to Z, which is lowercase alphabet, English alphabet. So no spaces, no punctuation, punctuatio, no uppercase, no Unicode surprises. Okay, that's basically easy question, but not easy for us or for me. Okay, now we have easy understanding summary of this problem. We've seen some examples. Probably it shows up here, and we understand the constraints. Now let's go to the explanation of solutions. And for this problem, we have two possible solutions. The first one is 2 pointers. What it means? So we can treat each string like a line of characters going from left to right. Here, check the one string, check the other string, and we are using pointers. So the first is I, the second is j, and it's pretty easy. We go for the first string, we assume the pointer is I. For the second string, we assume the pointer is j, and we just repeat it until the both strings are finished, or one of them. And actually, the 2 pointers solution automatically handles one string as earlier. So if in this case, for example, if word 1 is already finished, word 2 is actually like it's larger, but when word 1 is finished, we just append to the end the word 2, the remaining, the leftovers. Yeah, and actually this solution 2 pointers it will skip the empty one and keep taking from the other string. So here's the example. So word 1 is, for example, ABCD, the example for myself. Word 2 is XY. So we just start from I0, J0 from the 0 indexes, and we take word 1, so which is A. Then we take from word 2 J index, which is also 0, X, and we have AX, and then we basically do the same, repeating it until J is reached to the end here, yeah, 0, 1, which is two characters, and we only take from word 1. Yeah, and basically it's really easy. And why this is the right first approach? Because it's very direct simulation of the problem statement. Yeah, we just going to for each string, we're going from one character, and then we go from the string 2. We also do the same actually things, and it's easy to reason about. And yeah, here we come to the complexity part, and actually I think I will do a separate video about big O notation. But for this problem, the time complexity is n plus m, because we go through each of the string. We go from string 1 and we go through string 2. That's why we have time complexity n plus m. And the space complexity is actually a constant time. I think so. Yeah, but it depends actually on the solution type. If we are using Java, I think it would be n plus m. But nevertheless, we're not gonna think deeply about this for now, I think. But this is not the main idea for now. Yeah, this is the 2-pointer solution, and what I will also show you a real-world case scenario about this. I have for the second solution as well, but for the first one, I want to give an example that I come up with, and actually it's pretty interesting. How we can think of this problem in a real-world scenario. And actually it's pretty fascinating thing, because the LeetCode problems itself don't tell you why we need this. And each problem is just it's like solving a mathematical problem, and if you're not interested in such problem, and if you're not going into details, it's not gonna actually the information will not basically store in your head. But if you're gonna rethink it and think about something interesting, in this case I have this example of thinking this problem as a load balancing problem, as a round robin processing. What actually is round robin? Round robin scheduler is a fairness rule for sharing limited resources. For example, it uses in CPU, in a network link, or even in some servers, and actually it has a lot of functionalities. And this system, as I said, allocates the resources. And in this problem, we can think of this as, for example, two queues of tasks. So Team A have a queue of tasks, a bunch of tasks, and Team B has also some number of tasks. And a round robin schedule alternates, so it takes the front of each queue. For example, we take tasks from A, then from B, and we actually do it in a fair way, as we allocate some time for tasks 1, and we allocate some time for team 1, and we allocate some time for team B in a fair way. Yeah. So each of this team have enough time to process their problems. So yeah, this is a real world scenario. And now let's actually go to the first solution. Probably I will do it just like this. I don't know, is it a good way of doing this or not? Okay. So first, what we need, we gonna do. So we have the indexes that we will go through, and we have to create a list. Well, using a list is pretty easy because in Python, I solved these questions in Python, and in Python strings are immutable, but list is mutable, so it's probably easy to work with lists, so we can do whatever we want. I think so. So while I is less than length of word 1, or j is less than length of word 2. Or what it means, we will loop while we have characters in both word 1 or word 2. And if I is less than, so length of word 1, I think, if I'm not mistaken, we append the list. We append the list with word 1. Yeah. Not mistaken. If I'm not mistaken. Yeah, this is correct. And we increment the I. And we actually do the same with j in this order. 2. And append 2, j, and also increment in j. Basically, this is all, but in the end, we just return an empty string by joining the list. And actually, this is the solution. Let's check. Yes, it's correct. I think I will not submit it because I already did and it works. So yeah, basically this is it for the 2-pointer solution. This is it for a 2-pointer solution. Now we have the next possible way of solving this question with one pointer. Actually, I'm not going to show you the solution itself. I mean the code. Okay, I will show you, but I'm not going to explain it in details. Actually, the one pointer solution is has the same time complexity and space complexity. So, yeah, but the main idea here, we instead of two pointers as I and j, we just have a one pointer and an index that tells you where you are. And we use one index, and at each k we try to take word 1 and word 2, and it's just a shared step counter. And basically, here's the example you can see, and the idea is one loop index drives the process, and you check if each string still has a character at that index. Yeah, actually, probably this is not the problem. It's not so hard problem, so that's why the idea is also not a tricky one. And in the real world scenario that we have, and we have here's the example. So team A and team B also had some number of tasks with, for example, team A has length 4 of tasks and team B 2. And now you're scheduling rounds using one counter, like first key 0, we try A0, then B0, and we do the same, repeat it until, for example, we found out that B already doesn't exist, so B2 doesn't exist, B3 doesn't exist, and we just continue with the team A tasks. And here we have final order. And what also we have here, but we are in the solution. What we do here is solutions. So this is solutions. We have basically we are going for key in a range where we are taking the max of length of word 1 over word 2, and the indexes will be the max of these words. For example, here we have 4 tasks, here we have only 2, and we will loop through the maximum of tasks. So 4, then we will go looping 4 times, so which means from index 0 till index 3. So this is the solution for merge strings alternately, and yeah, this is all for today, and I will come back tomorrow with a new problem, which is next into programming skill set. I think that video was helpful for you, so goodbye.